Here we're going to look at structural isomerism. We defined in an earlier video structural isomerism as being compounds of the same molecular formula in different structural formulas. We're now going to look at the three different types of structural isomerism. The first of these is chain isomerism. Chain isomerism occurs when the carbon chain is arranged differently. So the simplest molecule which exhibits chain isomerism is C4H10. So there are actually two different ways in which the carbon chain here can be arranged. The first of those is where 4 carbons are arranged in a row. Now, I will just say now that I'm not putting these hydrogens in because it would take too much time, but we'll assume there's hydrogens at the end of these bonds. And we can see there we've got 4 carbons in a row. There is only one other way in which that carbon chain can be arranged differently. And that is like this. So we can see here the carbon chain now is arranged differently, and that's methyl propane. We don't need the number because it can only be on carbon number 2. So let's just have a quick look at C5H12. What are my chain isomers with the formula C5H12? Well, again, the simplest way, the simplest isomer to draw is the one where all 5 carbons are in a straight line, and that would give me pentane. There are 2 other ways in which we can arrange that carbon chain. First is where we put 4 carbons in a row and one of the carbons is on one of the centre carbons. Now that gives us methyl butane. Of course, if the methyl group here was on this carbon, then it's still methyl butane. You've just flipped the molecule around. The third and final way in which this carbon chain can arrange itself is as follows. And that is dimethyl propane. So they are examples of chain isomers. If I went up to C6H14, the number of chain isomers would increase. So the number of chain isomers increase as the molecular formula gets more complicated. Second type of structural isomer is position. And here the functional group is on a different position on the carbon chain. Simplest, or one of the simplest examples we can look at is propanol. So we've got an alcohol functional group here, and that is placed on, if I number it, carbon number 1. So here we have propan 1-ol. A position isomer of propan 1-ol, that is that the OH, the functional group, must be on a different position on the carbon chain. So the OH group will be on carbon number 2. So again, it's my functional group, and it's now placed on carbon number 2, propan 2-ol, a position isomer of propan 1-ol. Now, I'm going to ask a question now which will hopefully encompass both chain and position isomers. I'm going to ask, if I've got but1ene, I'm going to draw the structure of but1ene. Could we draw a position and a chain isomer of but1ene? So we've got my alkene there, That's my functional group, and we can see that it's on carbon number 1. The double bond is on carbon number 1. So I'm asking, can we draw a position and a chain isomer of but1ene? Well, firstly, we'll look at the position isomer. So we've got to put the functional group, that is the alkene, on a different position within that carbon chain. And the only place we can put it then is, instead of being on carbon 1, it's now on carbon 2. So that's my functional group. And now you can see that it's on carbon number 2. So that but2ene would be a position isomer of but1ene. A chain isomer of but1ene. I've now then got to arrange my carbon chain differently, so it can't be 4 carbons in a row. And because there's only 4 carbons, there's only one possible way we can do this, and that's put a carbon in the middle, like that. But we still need a double bond, and that is methyl propene. And we can see there, rather than being 4 carbons in a row now, it's a chain isomer because the 4 carbons are now not in a straight line. The last type of structural isomer we're going to look at is functional group. And here we've got molecules of the same molecular formula, but there are basically molecules with different functional groups. There are many examples of functional group isomers, but I'm only going to take you through the most common 3 you'll get at A level. The first of these is alkenes and cyclic alkanes. Both have a general formula of CnH2n. So for example, C5H10. So when you see that molecular formula C5H10, you should be thinking, well, that could be an alkene. So for example, it could be any alkene, but I'm just going to give us the simple pent-1ene. But it could also be a cyclic alkane. And the simplest cyclic alkane we can draw is cyclopentane. Could be methyl cyclobutane, which would be this molecule. Any cyclic alkane would do. The next pair of functional group isomers that you're likely to come across is aldehydes and ketones. Both have a general formula of CnH2nO. So for example, C3H6O, that could be an aldehyde or a ketone. Obviously, if it's the aldehyde, it will have the following structure. So you've got your aldehyde functional group here, but C3H6O could also be the ketone. And your ketone functional group is here. The final pair of functional group isomers you may come across are carboxylic acids and esters. Both have a general formula of CnH2nO2. So for example, C4H8O2. So the carboxylic acid, there's more than one option, but we'll go for the simplest, where all 4 carbons are in a straight line, and that would give us butanoic acid. But C4H8O2 could also be an ester. And again, there's more than one possible ester that we could draw. But again, we'll go for probably the simplest one. And this ester is ethyl ethanoate. So they are the most common functional group isomers you're likely to meet. So when you see molecular formulas such as CnH2n, it could be an aldehyde, an alkene, or a cyclic alkane. CnH2nO, for example, C3HXO, could be an aldehyde or a ketone, and CnH2nO2 could be a carboxylic acid or an ester. So they are the 3 different structural isomers that you need to be aware of.